Okay, so development of the periodic table. So humans are aware that there are forms of matter called atoms or elements. From ancient times, maybe from at least 500 BC, people do aware that there were uh, different types of matter exist in nature that you could isolate and use it for different properties. Most notably, people were previously aware in the ancient times about iron or carbon. Those are two popular examples. And here on the slide, you could see that different elements identified at different times. And you could see that by 1843, people have a good idea about at least close to 40, 50 elements, or maybe 30, maybe not 40, 50. At least by early 90s, we are aware of close to 60 elements for sure. And you can see that ever since first landmark of 1843, where we are able to find a majority of these elements by this time, all of these, if you have a hard time in identifying this list of elements where we were able to identify them by 1843. So this is the list that we are able to identify the elements from 1843. And there were few that identified between 1894 to 1918. Especially here is the element that I want to speak about in this category. Let me use another color to highlight other elements that are identified during this time. These two, polonium and noble gases. So why I want to highlight radon is it is a radioactive material that Madam Marie Curie from Poland, I guess. Yeah, from Poland. She received she is one of the only 5 women that received the Nobel Prizes in science, and she actually received 2 Nobel Prizes in 2 different major science fields. She received one in chemistry and one in physics. And the one she received in chemistry is for her contributions towards identifying the radioactive material radon. Before that, we do not really know that matter exhibits natural radioactivity. So her contributions leads to the identification of radioactive materials. And unfortunately, that research actually affected her health adversely, and she died pretty young while she is working on that experiments to identify the radioactive materials. Her health got deteriorated and died in next couple, if not in next 10 years. Very sad, but her contributions are greatly appreciated in science world. And there are many other elements that were found lately. Let me use another color. So if we talk about after 1965, most of these elements here are found after 1965. One of the reasons most of these elements that are found after 1965 is because they were man-made elements. We started synthesizing elements after knowing that different elements with a large atomic number, large number of protons exist that we can make and can nourish those properties for different, making catalyst, for example. So if we are able to make a new element, it is always a good thing, but not always they were highly stable. So it is a challenge to make a new element. So apart from when these were identified, here in this slide, we are just going to briefly speak about, the major landmarks in the development of the periodic table. The major landmark came in 1864, where John Newlands first identified that if we have elements with a different number of atomic number, he identified that every other 8th element is showing similar properties. So he called it as Law of Octaves. And after that, in mid 19th century, It is in 1867. Dmitri Mendeleev, a Russian chemist, and Lothar Meyer, a German chemist slash physicist. At the time, they used to do research on both chemistry and physics as a whole. So both of these independently and simultaneously at the same time come up with this idea of periodicity. If this term periodicity sounds too sciencey for you, you can think about general life examples where we speak about periodicity as for example, if you talk about magazines like Time magazine, for example, they were called periodicals, which means they publish periodically, like every week or every other week they publish. So they were called periodicals. So periodicity is basically talking about atoms that are grouped together that have similar properties but comes periodically, like John Newlands find in 1864. He finds that every other eighth element periodically coming to show similar chemical and physical properties. So it is called or named periodic table because of this reason, because every now and then a atom is shown to have similar chemical and physical properties with the previous atoms from 8 protons ago. And by the time when this Mendeleev proposed his book on periodicity of elements, we only know about 66 elements, and after that we came to know about rest of the elements. Currently we have a total of 118 elements in the periodic table. One of the contributions Mendeleev did to the periodicity is, even though he only knew about 66 elements by the time he published the book on periodicity and periodic table of elements, he actually did not give up and leave many blanks in his proposed periodicity of elements. He actually, even though he doesn't know what element it is going to be, he actually incorporated the data and predicted the properties of the elements if once we are going to find them in future. So even though he doesn't know which element it is going to be, because by the time they don't know, by 1870s, he basically predicted the properties of few elements that were yet unknown by the time. For example, gallium. He predicted the properties of it, even though he doesn't know that there is an element that is called gallium that is going to be found. Okay. It's a bit cold in here, I'm shaking. Okay. Here we are going to talk a little bit more about periodic table. Here basically just reinforcing what I just said in the previous slide, that Mendeleev come up with this idea of predicting the elements based on their proposed number of protons and number of electrons that is going to be, and what chemical properties they are going to exhibit even before we identify them. And another major discovery is until early 1910s, like we discussed in chapter 2, where we talked about gold foil experiments, we have no clue that there are elements that exhibits radioactivity, that we label it as part of them as X-rays. So Henry is the one that discovered that few elements will have X-ray generation properties. So one of the, if there are any disadvantages of early periodic table, is that in early Mendeleev or Meyer's periodic table, they relied of adjusting the periodic table trends on atomic masses of the elements rather than atomic numbers. So sometimes there are some discrepancies, like for example, by the time Mendeleev proposed this periodic table, they do not know that there are going to be elements called noble gases. Noble gases, if you see here, they were found sometime between 1894 to 1920s. So by that time, they do not have noble gases. So his theory couldn't able to explain why, for potassium is arranged in front of argon until we repropose to organize the periodic table based on atomic number, which is based on number of protons, not based on atomic mass, because atomic mass sometimes can have discrepancies with its previous elements in the periodic table that has less number of protons than the element that has more number of protons for different reasons. Okay. So before you answer this question, we do spoke about this topic already a little bit in our previous chapters. The reason behind the arrangement of elements in a periodic table is that within a group is called a tall columns from top to bottom. Within a group, usually the elements will shown to have a similar chemical and physical properties. Here the question is asking you to identify what elements would you expect to exhibit properties most similar to that of chlorine. Okay. So chlorine, first of all, if you have the periodic table with you, which you should for this chapter, for the entire chapter, while you're listening to this lecture, first you need to find where the chlorine is in the periodic table. Okay. Once you find that, you need to look around at the top or bottom for the group number. Usually the group number is given on top of the periodic table that chlorine belongs to. So if you check for that, like I'm going to show you here, here you should find chlorine.